Hello, today we are again here to discuss about some MCQs from the lesson. Which lesson we are doing? Permutations and combinations. Yes. So let us start with the first question of today's class. For this, I have to give you a question. Let me give you. Total, there are 4 gentlemen, 4 men, and 6 ladies. They are forming a committee, a group of 5 members. So they have to select 5 members so that gentlemen are always in majority. So that men are in majority. So in how many ways it can be done? Number of ways you have to find out. So first of all, I will make men column 4, ladies column 6. Remember, total 5 has to be selected. So men should be in majority. From 4 men, we will select 4 men. After that, one more member we have to select from the ladies. So we have selected 5 members for the committee. Our work is over. But it can be done in another way. From 4 men, you can select 3 men, and the remaining 2 members for the committee can be selected from 6 ladies. So this work is also over. Another work is also complete. Next, you cannot take from 4 men, selecting 2 men and remaining 3 from 6 ladies. This you can't take because men are not in majority. Men should be in majority. So only 2 cases. Now, 4C4 is 1. 6C1 is 6. 1 into 6 plus 4C3. Start with, actually 4C3 can be written as 4C1 and 4C1 is 4. 6C2, start with 6, take 2 numbers by 2 factorial. That means here you have 6, here you have 60. So total 66 ways are there to select members for the committee. Okay, next we will start. Next we will take the next question. If you have NC0 plus N plus 1 C1 plus N plus 2 C2 and so on plus N plus R CR, what it is equal to, that you have to find. So what we will do is, we will take first NC0 plus N plus C1 and the remaining we will keep as it is. We will not add them. Do you know why? Because we will add them but not at a time. After some time we will add. Okay? Sorry, there was a call, so I had to end and come. And so in the last, we will keep N plus R CR, same. Okay, now I have to use one formula, that is NCR plus NCR minus 1 equal to N plus 1 CR. This formula has to be used if and if it is possible. But it is possible only if we have N and N. That means in the first, instead of NC0, because what is NC0? It is 1. Instead of NC0, we can write N plus 1 C0 also, because N plus 1 C0 is also 1. And then the remaining we will keep as it is. That is, I will write N plus 1 C1. Now I can use this formula which I wrote here. N. This is R. This is R minus 1. Compare with the formula. This is looking like NCR plus NCR minus 1. Looking like that formula only. So I can write N plus 1 CR. Now I will take the remaining. Next, I will pair these two. That is N plus 2 C1 and N plus 2 C2. Again, how this is looking like? Same as the formula. This is N. This is N. NCR plus NCR minus 1. So if you use the formula, what you will have? N plus 1 CR. And so on you have to take until N plus R CR. In the end, what you will have is, when the last pair you will take N plus R CR minus 1 and N plus R CR. This is what you will have at the end, pairing up like this. This is looking like N. This is R and this is R minus 1. So you are adding these two. When you use the formula, you will get N plus 1 CR. So this will be the answer. Let us go to question number 3. In 3, all letters of the word again are arranged. You are arranging permutation, and the words are written as in dictionary. So you are arranging as in dictionary. Then you have to find 50th word. Okay. So for that, what we have to do? First, take the letters of the word again in an alphabetical order. First A, then G, then I, then N. You are taking all the letters. So first you will have letters with the word starting with AA. So how many words start with A? If you take how many words start with A, you can erase this A. And what can you say? How many words? Total, we have taken 1A. We have 4 letters and 4 places. 4 factorial words start with A. After that, how many words, the next letter, start with G? So G is taken. We have 4 letters and 4 places, but 2 letters, 2 A's are repeating. So 2 factorial. So here 4 factorial means how much? 24. What is 4 factorial by 2 factorial? 12. Okay. After that, words starting with I we will take. Again, there are 4 letters. After removing I, 4 letters are there and 4 places are there, but 2 A's are repeating. So again, there are 12. So total 48 words became. So 49th word will start with N. Start with N means next it has to take A. After N, A should come. And after A, again A should come. After A, G should come. And after G, I should come. So this is 49th word. Then they're asking 50th word. So starts with A, starts with N, then A. Instead of G, now it will have I. So the last word will be G. Last letter you can take as G. This is the last word. This is the 50th word which they are asking for. Next is 4th question. The number of numbers that can be formed using the digits 0, 1, 2, 3, 4. Repetition not allowed. But you are using any number of digits. How many numbers can be formed? Number of numbers formed. First, there are 5 letters. So we will make 1 letter number. 1 letter number means 5 factorial. Isn't it? 5 words can be formed. There is only 1 digit in the number and you have 1, 2, 3, 4, 5 numbers. So 5 ways. Now 2-digit numbers we will take. For 2-digit numbers from 5, we have to take 2 and arrange. Next 3-digit numbers from 5, you have to take 3 and arrange. Next 4-digit numbers from 5, you have to take 4 and arrange. Next 5-digit numbers from 5, you have to take 5 and arrange. But what will happen is out of these, the first letter, if it is 0, that one you have to subtract, that one number. If the first digit is 0, then you have to subtract. How many numbers begin with 0? 0 already you have taken. So total 4 numbers and 1 place. Now, how many words start with 0 here? Because 0 is taken, you have to take 4 numbers are there and 2 places are there. These start with 0, so we are subtracting. All which start with 0, that we are subtracting. So here also we will subtract the number starting with 0. Because 0 is already taken, there are 4 numbers and 3 places. Next, the number starting with 0 for 5-digit numbers. Total 4 numbers are there. You have to take 4 numbers and arrange and subtract because they will be starting with 0. So what will be the final answer looking like? You will have 5 plus 5p2 plus 5p3 plus 5p4 plus 5p5. From all these, you have to minus 1 plus 4p1 plus 4p2. This is 5. This is 5 times 4. This is 5 times 4 times 3. The next one is 5 times 4 times 3 times 2 times 1. And the last one, 5p5. What is 5p5? 5 factorial. Then minus 1 minus 4p1. What is 4p1? 4. Plus, again this also minus, because minus goes to every number inside the brackets. Minus 4p2. 4 times 3. I did not write some more here. After 4p2, some more are there. Minus, you have to subtract 4p3 and 4p4 also. All the ones starting with 0 in the beginning. So what do you have? 4p3, 4p4 is 4 factorial. That means you will have 5 plus 20 plus 60 plus 120 plus again 5 factorial is 120 minus 1 minus 4 minus 4 times 3, 12. Okay, then minus 4 factorial 24. This 4 factorial also will be minus, because minus is distributed. So on simplifying this, you are going to get 260 numbers can be formed. Next question. There are 8 different flowers, out of which 4 particular flowers are never separated to make a garland. So in how many ways? Number of ways. So first garland will be like this. Because there are 1, 2, 3, 4, 5, 6, 7, 8. 8 different flowers, and 4 particular flowers are never separated. They are together. So we can count them as 1, 2, 3, 4, 5 flowers. 1, 2, 3, 4, 5 flowers. They can be arranged in 5 minus 1 factorial. After that, these 4 flowers will arrange among themselves in 4 factorial. But because the flowers are after all flowers, so clockwise and anti-clockwise are not taken. That is why you have to take half of it. Half will be clockwise, half will be anti-clockwise. So that means half into 4 factorial, 24 into 24. And that will give us 12 into 24. But how can you write this 12 into 24 as? This 12 into 24, when you multiply, you will get 288 ways. Let's go to question number 6. A class is composed of, in a class, there are 2 brothers and 6 other boys and remaining 6 boys. So in how many ways can all be seated around a round table? These are seated to be at a round table, so that no 2 brothers are seated. The 2 brothers are not seated beside each other. 2 brothers are not beside each other. Let me erase this. Yes, 2 brothers are not beside each other. This is the question, and you have to find number of ways. So, first of all, what we have to do here, total 6 boys are there. We will arrange them in a circle. B1, B2, B3, B4, B5, B6. We will arrange them in a circle in 6 minus 1 factorial ways. Now the 2 brothers are not to sit beside each other. That means they have these options so that they will not be beside each other. So there are 6 places and 2 brothers has to be arranged. Now the work is complete. 5 factorial into 6p2 is 6 into 5. Start with 6 and take 2 numbers. Now 5 factorial is 120 into 6 into 5. So that becomes 3600 ways. Let's go to question number 7. The number of ways of arranging the letters A, 5 A's, B, 3 B's, C, 3 C's, D, 2 E's, and F in a row, then no 2 C's are together. So you are arranging the letters. Arranging the letters so that no 2 C's together. So, without any hesitation, if you see how many letters are there, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Isn't it? Total 15 letters are there. So what I will do, I will arrange these 15 letters. But because they said no 2 C's are together, leave these 3 C's. You will have 15 minus 3 letters. That is 12 letters are there. So without any condition, we are arranging these 12 letters. That can be done in 12 factorial by 5 factorial, 3 factorial. All the C's are together. And then EE, 2 factorial. This is how 4 letters word can be formed. But out of these, you have to subtract all those letters which have 2 C's together. Now, how many letters have 2 C's together? Suppose if you keep A, 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 B, 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 D, E, E, F. No 2 C's together means how many places? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Total there are 13 places. You have to take the C's. 3 C's you have to take and arrange them. But then you will divide by 3 factorial. Why are we dividing by 3 factorial? Because why are we dividing by 3 factorial? The places for C's. We are seeing 13 places for C's and we have to select 3 places. Because the 3 C's are same, we are dividing by 3 factorial. That is the answer. Next, question number 8. 8 chairs are numbered 1 to 8. 4, 5, 6, 7, 8. Total 8 chairs are there. 2 women and 3 men are supposed to sit on 1 chair each. First, the women choose the chairs among the chairs marked 1 to 4. In these marked 1 to 4, women chooses. First, that is the work. So, in how many ways women can choose here? Total 4 chairs are there. They have to take only 2 women and arrange them in all possible ways. After any 2 of the chairs are occupied, now there are 6 chairs and 3 men. You have to let them arrange because our work is over. Next, question number 9. Total there are 6 pluses and 4 minus symbols. You have to arrange in a line. The question is arrange in a line such that no signs, no 2 signs occur together. No 2 signs, or you can say no 2 minus signs. I'll give the question like that. So what is the condition? No 2 minus signs occur together. That's the question. So first we will arrange in a line all the 6 plus in 6 places. That can be done in 6 factorial ways. Now this minus signs, they have all these places. So total 7 places are there and only 2 minus signs should not occur together. Right? So first, what did I do? I have arranged the 6 positive signs in 6 factorial ways. Okay, 6 positive signs you have arranged in 6 factorial ways. Right? But what is happening? These all positive signs are same. No use of arranging them. I will tell you, instead of writing all these, total I have 6 positive signs. So 1, 2, 3, 4, 5, 6, all are looking same. No use of arranging them. So only one way is there to arrange the positive signs. Now, after arranging the positive signs, no 2 minus signs occur. So minus sign has these places. How many places are there? 1, 2, 3, 4, 5, 6, 7 places are there. So total 6 minus signs are there. I am arranging 6 plus signs are there. I am arranging in one way. After arranging, now I have 7 places. And in these, I have to arrange the 4 minus signs. But the 4 minus signs look same. So 4 factorial, that means it is 7C4. So you have to multiply this one way into 7C4 ways. Final answer is 7C4. Next, question number 10. I am giving you the digits 4, 5, 6, 7, 8. They are written in all possible orders. The number of numbers greater than 56,000. So you have to find how many numbers are. I have no space to write here. So you have to find number of numbers formed are greater than 56,000. That's the question. So greater than 56,000 means already you have 5 digits and you have to make 5 digits. No other options. So because you are starting numbers greater than 56,000, the first one will be occupied by 5. Second one will be occupied by 6. Right? You have to make numbers greater than 56,000. So first one you have to take 1 occupied by 5. Let us take the numbers greater than 50,000. That is what they are asked in the question. So when you make the numbers in the ascending order, first place should be occupied by 5. Second place cannot be occupied by 4 because it will be less than 56,000. So either 4 occurs on the first place or 5. 4 occurs on the first 2 places. Right? Now you have 3 places left. How can you fill up? Already 5 and 6 are occupied because we have to take numbers greater than 56,000. The remaining 3 places and 3 letters can be arranged in 3 factorial ways. Now, apart from these numbers starting with 56, actually, you can take numbers starting with 57 also. They are also greater than 56,000. So, another 3 factorial numbers. Numbers starting with 58, another 3 factorial numbers. Then numbers starting with 6. So 4 factorial numbers. Numbers starting with 7. 4 factorial numbers. Numbers starting with 8. 4 factorial numbers. So this is 6. This is 6. This is 6. Here this is 12. This is 12. And this is 12. All these numbers which I have discussed now, they are greater than 56,000. So when you add up 12 3s 36 plus 6 42 plus 6 48 plus 6 54 numbers are there which are formed greater than 56,000. Are you missing any number here? Because repetition is not allowed. That is why all the numbers starting with 56 are greater than 56,000. Starting with 57 greater than 56,000. Starting with 58 greater than 56,000. Then starting with 6, they are greater than 56,000. Starting with 7, they are greater than 56,000. Starting with 8, they are greater than 56,000. Okay. Let us go to question number. Which question we have completed? Question number 10. So now we will go to question number 11. How many different arrangements can be made out of the letters in the word a square, b cube, c power 4? Number of arrangements of letters. So total how many letters you have? 2 plus 2 plus 4. But out of that 2 A's, 2 B's, 4 C's. So 8 over 2 times 2 times 4 factorial is 12. So 4 ones, 4 twos, 2 ones, 2 6. But here 1 by 6 is not correct. So what we have to do? How you can arrange? 1 by 6 will not be there in permutations and combinations. Factors will not be there. So what you have to do? Total how many letters you have? 2 plus 2 plus 4. This you have to take factorial. Because 2 A's are there repeating, 2 B's are there repeating, 4 C's are there repeating. Like this you have to take. So 8 factorial means 8 into 7 into 6 into 5 into 4 factorial, because down 2 into 2 into 4 factorial will cancel. That is why you have to write up to 4 factorial. Now left off is 2 fours, 2 threes. So that means 28 into 15. What is 28 into 15? 5 8s 40, 5 2s 10, 140, 8 and 2, 0, 12 and 4. So 420 ways are possible. Next question. The number of permutations that can be formed by arranging all letters. Which word we are taking? 19 word. You have to arrange all letters. No two E's are together. That is the condition. So what we will do is, we will first take N, I, N, T and N. We will arrange them, and that can be arranged in 5 factorial ways. Okay, after arranging these numbers, we have to see 3 N's are repeating. So write 3 factorial. Now because E's are not to be together, 1, 2, 3, 4, 5, 6 places are for E's, but there are 3 E's. So these 6 places we have to select for the 3 E's. This is the total number of ways we can do it. Next, let us go to question number 13. In question number 13, I am giving you few letters, few digits, 0, 1, 2, 3, 4, 5. You have to make a 5-digit number. Make 5-digit number. Remember, repetition not allowed. Repetition is not allowed. Moreover, when you are making these 5-digit numbers, they must be divisible by 3. So in how many ways this can be done? So for that, actually you have to make 2 sets. 1 plus 2, 3 plus 3, 6 plus 4, 10 plus 5. This set of numbers, 5-digit numbers, or 0 plus 1, 2 plus 2, 4, 0 plus 1, 1, 1 plus 2, 3, 3 plus 4, 7, 7 plus 5, 12, divisible by 3. Because 1 plus 2 plus 3 plus 4 plus 5, if you take these set of numbers, what are you getting? 15. It is divisible by 3. Similarly, 0 plus 1 plus 2 plus 4 plus 5, what are you getting? 12. This is also divisible by 3. Numbers formed by this set of numbers. So here we are making 5-digit numbers and we have 5 digits. So 5 factorial numbers are possible. Whereas if you take the other case, what is happening? Here also 5 digits, 5 numbers, 5 factorial. But some numbers will have 0 in the first place, then that will not be a 5-digit number. So you have to subtract such numbers. How many numbers will be there here? 0 is already occupied. 1, 2, 3, 4 numbers and 4 places. 4 factorial numbers start with 0, which we have to subtract. So here the work is complete, here the work is complete. So we are adding both the cases. 5 factorial is 120, 5 factorial is 120 and 4 factorial is 24. So total 216 numbers can be formed. Let us go to question number 14. In question number 14, I am giving you digits 1, 3, 5, 7. You have to find the sum of numbers formed that are greater than 1000. And remember, again, repetition is not allowed. So you know there is a formula for this. What is the formula? Already in the shortcut method I told you. First you will take all these digits and you will add them. Then because there are 4 digits, you will take 4 minus 1, 3 factorial. And then because there are 4 digits, you will write 4 ones and multiply. So here you will have 16. This is 6. This is 1111. That means 96 has to be multiplied to 1111, which will give us 1,06,656. That is the sum of numbers formed. Let's go to question number 15. I am giving you 47C4 and sigma 52 minus J C3. J is from 1 to 5. What will this be equal to? So 47C4 plus, when you put J as 1, 51C3. J as 2, 50C3. J as 3, 49C3. J as 4, 48C3. J as 5, the last number, 47C3. So in this case, everywhere we will be using one formula. And that formula is NCR plus NCR minus 1 is N plus 1 CR. So for that, first I will take NCR plus NCR minus 1. This will give me N plus 1 CR. Okay. Now because I got 48C4, I will take this 48C3 and add. So I will have 49C4. Okay. Once I got 49C4, to this 49C4, I will add 49C3. Which will give me 50C4. To this 50C4, I will add 50C3, which will give me 51C4. To this 51C4, I will add the last number, that is 51C3. That will give me 52C4. So this is the final answer. We have been using the same formula again and again. That is only the technique here. Okay, we will go to question number 16 now. In question number 16, I am giving you NCR minus 1 equal to 36, NCR equal to 84, and NCR plus 1 equal to 126. You have to find what is R. So here we will be using one formula. You must have remembered this formula. If you have NCR by NCR minus 1, it can be written as N minus R plus 1 by R. So if you use this formula here, I will take NCR by NCR minus 1, that is 84 by 36. What is 84? 12 sevens, 12 threes. So I have N minus R plus 1 by R is 7 by 3. Similarly, the same formula NCR plus 1 by NCR I will use. 126 by 84. So here also if I use the same formula, N minus R minus 1 plus 1 by R plus 1. This will be 6 twos, 6 ones. Then here 6 ones, 6 fours. 7 threes, 7 twos. 3 by 2. This work is not yet over because I have to find R. Okay, so here I will write N minus R plus 1 equal to 7R by 3. N minus R equal to 7R by 3 minus 1. Why am I finding N minus R? Because here also I have N minus R equal to 3 by 2 into R plus 1. So here also N minus R, here also N minus R I got. So I can set them equal. That means 7R by 3 minus 1. I can set equal to 3 by 2 into R plus 1 to solve this equation. 7R minus 3 by 3 equal to 3R plus 3 by 2. 14R minus 6 equal to 9R plus 9. 14R minus 9R equal to 9 plus 6. So 5R equal to 15, R equal to 3. On solving this equation, our work is, see the question, our work is to find R, and we did that. Coming to question number 17. In the next question, I will give you N minus 1 C6 plus N minus 1 C7 is greater than NC6. Then, how will you solve this inequality? Again, I can use the same formula NCR plus NCR minus 1 is N plus 1 CR. So if this formula is used, I will have n minus 1 plus 1 CR greater than NC6 or NC7 greater than NC6. NCR formula is n factorial by n minus r factorial into r factorial. NC6 is n factorial by n minus 6 factorial into 6 factorial. First of all, I can cancel n factorial. Then on cross multiplying, n minus 6 factorial into 6 factorial is greater than n minus 7 factorial into 7 factorial. Now, n minus 6 factorial, I will write n minus 6 into n minus 7 factorial. 6 factorial, I will keep same, greater than n minus 7 factorial, same, but 7 factorial, I will write 7 into 6 factorial. So that I can cancel 6 factorial, I can cancel n minus 7 factorial. So I will get n minus 6 is greater than 7 or n is greater than 13. Until here, I can solve this inequality and I can leave it. Going to question number 18. A lady gives a dinner party for 6 guests. Total 6 guests are there. So she wants to give party only for 6 guests. Total she has 10 friends. But 2 friends, they don't want to attend the party together, will not attend party together. That's the situation. So in how many ways she can invite? That's the question. So first of all, from total 10 friends, she has to select 6 guests and invite them to party. But what is happening is, as 2 friends will not attend the party together, so there are some cases where, because 2 friends are not attending, only 8 friends are left. From 8 friends, because 2 friends are not attending the party, what we are doing is we will take opposite of it. Like we will take 2 friends attend the party, opposite case. So if 2 friends attend the party, out of 10 friends, you will subtract 2 friends. So now she has 8 friends left off. From 8 friends, because 2 friends are already guests, they are coming to party. Left of guest she has to select is 6 minus 2, 4. So if 2 friends attend the party, she can select in 8C4 ways. But because they are not attending the party, you have to subtract this case. And in this way, you will get the answer. So how will you get the answer? First 10C6. 10C6 is same as 10C4, I can write. 10C4 means what? Start with 10, 9, 8, 7. Take 4 numbers and 4 factorial. 4 2s, 8 will cancel, 3 3s. So you have 210 What is 8C4? Start with 8. 8, 7, 6, 5 by 4 factorial. 4 into 3 into 2. Cancel. Then 4 twos. That means 60. From 210, you have to cancel 60 plus 10, that is 70. And that will be 210 minus 70 will be 140 ways. That means she can invite the guest in 140 ways. So I think today we have done lot of problems from permutations and combinations. Tomorrow will be the last day to complete these multiple choice questions. So learn well and come, so that after tomorrow we can go to the next chapter. The next chapter is binomial theorem.